Okay, so this is the last, finally, to the last section, last topic of chapter 7, and it's really going to go back and look at conditional cases with trees again, and we're going to add one more question that we can ask with trees. So I'm actually going to review a little bit of the tree applications, and so if you really understood 7.5 part 2, the setup for this is going to be very similar. We're just going to add one more type of question that we can ask, and it is a conditional type. It's a special type of conditional which we use Bayes' theorem and formula to answer it. Alright, so it is the tree cases again. So this will be an application where you're given conditional events, you can set up a tree, and then after we set up the tree, we're going to ask you a type of question where you have to use Bayes' formula to answer. Now, just so you're aware, the WebAssign uses the formula, and it has it all written out, which sometimes with just all the lettering and stuff, it can look a little complex. I just suggest you use kind of my method instead, where it's the tree and the setup. But I'll show you what the formula is in this case, but they do make it a little cumbersome with all the notation, so just be aware of that when you do the WebAssign. Alright, so a tree, suppose that we have 3 initial events. So R1 is event 1, R2 is event 2, R3 is event 3. And then, so that's the first set of events, so you could be either R1, R2, 3. And then after that, T will happen or T won't happen. Alright, so there's a set of branches, there's 3 of them first, and then there's 2 sets of branches after that. Alright, so partitions just means they're mutually exclusive events. You're either in event 1, 2, or 3. You can't be in event 1 and event 2 at the same time. Alright, and so that's all that formal thing. That's all that means. Alright, so the R events come first, and then the T or the not T. Right? Now either your T happened or T didn't happen, and then all outcomes. Now I'm just going to focus on the T, so I'm just going to write out the T case. Since we've done trees before, that's the only case that I'm really interested in when we get to the Bayes formula. So, I mean, when I draw it out, I'll explain what I mean. Alright, so R events, there were 3 R events. I have the first R event, the second R event, and the third R event. So R1, R2, and R3. Alright, whatever they are. And then after these 3 events can occur, either T will happen or T won't happen. Alright, T will happen or T won't happen. T will happen, T won't happen. I'm actually not going to list out all the possibilities. I'm only going to list out the possibilities where T happens, because that's the one I'm actually interested in when I get to the next set of notes. And so I'm only going to list out the probability of event 1 and T, probability of R3, or R2, not R3, R2 and T, and the probability of R3 and T happening. Alright, so remember, these probabilities are, this is the probability of first event happening, this is the probability of the second event happening, this is the probability of the third event happening, and in the application, it should give you, if not all 3 of those probabilities, it should give you at least 2. Then you use the fact that those are all of the first events, and they should add up to 1, right? And so again, those would be all the probabilities. And somewhere in the application, they either give you 2 of these, or they give you all 3. Then remember, the second set of branches are the conditionals. So these are conditionals. Right? I can only get to the second set of branches if I've completed the first event. Right? So this, remember, given we're on the first event path, so if route 1 happened, if event 1 happened, this is the branch I'm looking at, since I'm only interested in T. This would be the probability T happens given event 1. And then you multiply those out to get to this event, right? This is the product along the tree branches. Same thing here. This is the conditioning. If I know I'm down route 2, event 2, to get to T, then it's the probability T happens given event 2. And then the third one, same thing. Probability T happens given event 3. We find our AND probabilities by multiplying down those paths. So that's nothing new. That's all stuff we did in 7.5. The new question is just the new type of conditional, right? We have conditionals on our tree, which we found before in 7.5 part 2. But now we have this new, so this is a new question. Right. We want to find the probability of event 1 happening, R1, but we're given that T happens. So this is a conditional probability. And we've never seen one of these before with the tree cases. And so what it is we were given the end results, right? We were given T occurred. So I know that on one of these results where I ended in T. Right? And that's all I know. All I know is T occurred. I don't know if it came from the first event and then T, the second event and then T, or the third event and then T. And so all I know is I'm given T happen. And so this is the conditional probability. Well, what's the probability it came from the first event, given I know T occurred? Well, this is the conditional formula. So remember, the conditional formula is the probability of the given event, so probability that T occurred, because that's my given. And then the up top is the probability of the and statement, the two events I'm looking at. So the probability it's the first event and T. All right, which is the end result of my tree, right? That's the end result of my tree. The tricky part is what I divide by. And this is where it gets a little cumbersome when you look at the web assign. I think it's just easier to go up and see, well, how could T happen? Well, there are three ways T can happen, and I have to add up those three ways to figure out what's the probability T will occur. And so in the formula, they have it all written out the ways T can happen. And so if we write it all out, up top stays the same. That's the probability event 1 and T. In the bottom is the sum of all of the outcomes that ended in T. And so this would be the probability it was the first event and T, plus the probability it was the second event and T, plus the probability it was the third event and T. Right? Those are all of the ways T can happen. And that's actually if we have the formula all written out. Now, like I said, when we usually do the problem, it's easier just to find this. I just go and add up these three outcomes, and that's the way T will occur, right? If I take all of those three probabilities, add them up, that's the probability T will happen. And that goes down here. And then up top is the one outcome we're looking for. Well, this is the one outcome we're looking for, and so that number goes up top. All right, and so don't be confused. They are in both spots, and they need to be because this has to happen, right? That's the one of the ways T can happen. Out of that one way T can happen, what's the probability it does? Well, add up all of the three cases where T can occur, right? That's the given, all of the ways T can happen. And then I divide that, that's what I divide by, right, into the case I'm looking for. All right, so Bayes formula, more formally written out in words, I guess. All right, so Bayes formula, if we want to find the probability of R1 given T, where T is the end result of my tree branches, up top is the product, right, the multiplication between the branches going from the first event to T, right, getting to that end result. In the bottom is what you've got to remember. It's the sum of all of them, including this one, where it ends in T, because T is my given statement. And so, again, it's not technically anything new. It's sort of combining two concepts that we talked about in Sem 5. It's the conditional formula, right, that's what this is, the conditional formula, with the tree outcomes. And you kind of have to combine them together. So I have to add up the tree outcomes, the ending events in T, and put them in my conditional formula. So it's kind of combining two concepts from 7.5. So I'm going to do a simple example, and then we'll get to applications in the next video. Alright, so a general example, just kind of a generic one with numbers and things. Right, so I've got my tree here. So this would be my events, my first events, and events A, B, C. Those are my first events. And then the second set of branches are D or not D, and then all my outcomes. Now, I know, I'm going to go down here, that I want to find D. So I'm actually only going to do the D part. I'm not going to do the D part. If you want to fill out the whole entire tree, you can. But I know that my question's just asking me for the probability that D occurred. So I'm only going to do the D outcomes, because that's all I need to answer my question. Alright, so that's just, I'm not going to completely fill out my tree. I'm only going to fill out my tree that end results in D. So I'm only going to find these. Probability of A and D, probability of B and D, probability of C and D. Alright, now if you want to finish the tree, you can. If you just like to make sure you have a complete tree, feel free to do that. Alright, so I've got to fill out, there's some blank spots. Remember, everything kind of adds up to 1. So the first event A has a 0.45, the second event B is 0.5. I'm missing event C, but remember these are all of the events that occur in the first case, and so they should add up to 1. So that's 0.6, so that means this has to be 0.4, right? That's 100% of my first outcomes. Right, so those add up to 1. The second set of branches, I'm going to finish it out just so that you can see. You don't really need it because the 0.3 is what I need, but this would be 0.7. Remember, that adds up to 1. Those are all of the ways D can happen or not happen given A. These are the outcomes where all of the ways D can happen or not happen given B. Well, this is 0.25, which makes this one 0.75. And then the last one, given C, this is the way D can't happen, so I need this one, which is 0.85, right? That's the probability D will happen given C. Right, now I've completed the tree part, now it's the end result. And so remember, the end result is to multiply. So the first one's going to multiply 0.45 times 0.3, which comes out to a probability of 0.135. And don't round, leave it exactly 0.135. Same thing for the next one. The next one is 0.15 for the probability of B, 0.75 for the probability of D given B. And again, don't round, write it exactly 0.1125. And then the last event that I'm going to find, probability of C was 0.4, probability of D given C was 0.85, multiply that out, 0.34. Now again, if you want to find the other missing probabilities where D did not occur, it's up to you. I'm not, those are the only ones I need to answer my question. Alright, so the question is, find the probability of C, right, this is the probability of C, given D happened. Alright, so it's a conditional, and it's not one of the conditionals on the tree, and so the formula would be, it's the, again, you divide by your given, what's the probability of D? Up top is the and statement, what's the probability C and D happen? And I needed the tree to get me there. Right? The probability of D are all of the outcomes that end in D, right? These are all of the ways D can happen. And so I add up these three events to find the probability of D, right? The probability of D is our 0.135 plus our 0.1125 plus our 0.34. And so the probability D happens, right? Those are the three ways I can get to D. Either I can go A to get to D, B to get to D, or C to get to D. And so I add up all of the ways D happens, so those three outcomes add up to 0.5875. Alright, and so that's the probability that D occurs, which means the complement to that would be the probability that D didn't happen. So again, that's the only one I want, and so that's what I'm going to divide by. So that's the division part. Alright, so that's this bottom number, right? Probability of D occurring was 0.5875, and then up top is the case I'm interested in. So this is all of the ways D happens, right? A and D plus B and D plus C and D. Well, out of all of those ways D can occur, what's the chance that it was the C route that it took? All right, so I need my and statement for C, which means I use this one again, right? Out of all of those outcomes, 0.34 were the outcomes where C occurred. So I put 0.34 where C and D occur, and then you do the division again. Alright, so you divide those two numbers, so the probability of C given D is 0.34 divided by our 0.5875, which comes out to, if I round a couple decimal places, 0.579. Alright, and there's the probability in that generic case. So this is just again giving you a generic example of this case. So again, technically it's nothing new, Bayes' theorem. It's sort of combining two old concepts together. The tree cases with the conditional formula. You need the tree because it's a part of this conditional bottom part. I need all the cases where it ends in D, in the end of my tree. Alright, so Bayes' formula, when it's the conditional case, is the end result. Right? If I'm given the end of my tree, and I'm working backwards to find the probability of, well, which is my beginning cases, which was my first event. Right, and that's when you have to do this Bayes' theorem. You have to set it up this way. So, and that's basically it. That's the last concept from chapter 7. And so the next videos will just be practicing applications. And I'm going to mix in some old rules, because on the quiz what I'll usually do is I'll give you a tree case, and there'll be questions from the 7.5 and questions from this new 7.6 on the tree cases. Alright? And so when we get to those examples, they'll be mixed together. So I'm going to stop the video there, and we'll pick up examples of this in the next video.